Jai Hind everyone. Myself Pradeep Kumar Tripathi, Assistant Professor in Department of IIT in AKGEC College, Ghaziabad. Today we have discussed lecture series of DBMS. Now we will discuss on topic functional dependency. These are the outlines which I have discussed in this particular lecture series. Functional dependency, types of functional dependency, attribute closure, Armstrong axioms, equivalence of the functional dependencies, canonical cover, and lastly we have discussed about the keys. What is the concept of keys? Super keys, candidate key, and primary. We can say about what is functional dependency. We can say that an attribute has a functional dependent on another attribute. Suppose A tends to B. That is, A tends to B, this one. B can be found on the basis of A. That means the B value can be dependent on A. It is called functionally dependent on A. That means the attribute B can be dependent on B. This is called functional dependency. Suppose we have taken the example of employee records. In the employee record, we have the employee email ID, addresses, and we can only track one email address for each email ID. So this email address can be dependent on employee number. This is called functional dependency. Suppose we have a relationship in a table relation R. We have a two attribute, that is A and B. A, that is the value of 101 and 101, and the value of B is Cn and Cn. This can be determinant, this can be dependent. So B is called dependent and A is called determinant in the functional dependency. Then we have another example like A and B, they are the two attributes, and the value of 101 corresponding Cn and 102 corresponding the DBMS, 103 is corresponding the DA. Then B is dependent on the A. This is the functional dependency. Another term, functional dependency can be the type of trivial and non-trivial. Trivial dependencies, that means AB tends to B and valid but not informative. In the non-trivial, we have suppose AB tends to B. This is a valid dependency, but this is not informative. In non-trivial dependency, AB tends to ABC. This can be valid and new attribute can be found. What is the new attribute? That is C. Suppose we have take an example of functional dependency. We have a relationship in a R and we have the 5 attributes A, B, C, D and E. And in this particular relation R, and these are the functional dependency, and first dependency A tends to B. On the value of A, we can found the same value of BC. On the same value of C, we can get the difference value of DE. This is the correct option. This is the correct option. These two options are, this cannot be defined by the C, cannot be dependent on DE. So from this example, we can easily understand the value can be dependent on the another attribute. Suppose we have taken the first example, AB tends to C, then B and C value can be dependent on the A. In the third example, DE value can be dependent on C, but second and fourth option, that is wrong in the functional dependency. That means they cannot be interchanged. Suppose we have more example on the functional dependency. This is the relation 1 and relation 2. Which one are the correct and which one is the wrong? So In this example, this one is correct and this one is wrong. This one is wrong because we cannot identify. In this example, in R2, we can also, this is wrong option, this is correct option, this is wrong option, because the value of A cannot be determined by the BC. So now let's talk about the closure. What is the closure? Closure of an attribute that can be defined as a set of attributes which can be functionally determined from it. It can be represented by the plus sign. We can denote it as a, suppose we have an attribute of A, then we can denote by this A plus. So from the first example, we can take the first example. One is R1, that is a relation. We have a 3 attribute A, B and C. And a functional dependency, we have given A tends to B and B tends to C. These are the two functional dependencies that given in the example. Suppose we want to closure of A. How can we find out the closure? We can find out the closure from A plus. A plus we can found, then A by itself is adding and A tends to B. That means V value can be dependent on A. So we can also include the attribute B. And B tends to C. That means C value can be dependent on B. Then we can add on C also. So what is the closure of A plus? The closure of A plus is ABC. That is the closure of particular A plus. We can denote it A plus and the attributes that can be added in a closure, that is A, B and C. In the second example, we can A, B, C, D, E, F. These are the attributes that we can use in second example. In the second example, these are the functional dependencies that we have to given. Suppose we have find out the closure of D plus. How we can find out? Then we can go to the functional dependency D. D tends to AF. Then we can add A and F, or D is by self adding. So these are the called ADF. Now ADF, so we can check another dependencies that can be related to these attributes A, D and F. One dependency is used, ADF, A, D and F, that can be also used, and A tends to B. This is also used in this particular closure. So finally we can add the attribute B in A, B, D, F. If I can find out the DE plus, how we can add? Then DE and DE related to the functional dependencies, this one. So we can add C part also. In the C part, then we can add F also. If we can use C and F, then we can use the E tends to CF. So all about the all attributes are coming into the this particular closure. DE plus contain all the attribute of this particular relation. So this is the way that we can find out the closure of an attribute that is used in a normalization. Suppose we have some axioms that we can use in a particular normalizations. So what are the Armstrong's axioms? The basic three parts, that is called reflexive, augmentation and transitive. These are the three inference rule that comes under the Armstrong axioms. In the second inference rules, these are the some other rules that can be also used in a normalization. So let's talk about the inference rule reflexive. If y is a subset of x, then x tends to y. This is called reflexive inference rule. In augmentation, we can x tends to y, then x multiplied by z and y multiplied by the z. Then it is also true if x tends to y, then we can, if multiply, we can s, suppose, then x s y s. This is also true because x tends to y, then it is also true. This is called augmentation rule. What is transitive rule? In the transitive rule, we can, if x tends to y and y tends to z, then it is implies that the x tends to z. This is called transitive rule. And these three inference rule cumulative called is reflexive, augmentation, and transitive. These three inference rule makes the Armstrong's axioms. Some another inference rules are there. Union, if x tends to y and x tends to z, then we can combine these two attributes in the right hand side. That is also called x tends to yz. This is the union rule. Another rule is decomposition, that we can decompose the functional dependency x tends to yz, then x tends to y and x tends to z. This is called decomposition rule that can be used in a particular relation. We can also, these rules can be implemented in the normalization. When we talk about the normalization, then we can use this type of functional dependencies rules. That is inference rules. Pseudo transitive, if x tends to y and y tends to z, then wx tends to z. This is also pseudo transitive rule. That is proof. This is x tends to y and we have multiplied both sides w, then we got the wx tends to wy. This is augmentation rule. We can multiply in the both sides. There is no difference in the value of wx and wy. We have already the functional dependency wy tends to z by using the transitive dependency. So we can say about wx tends to z. This is called pseudo transitive dependency. Yeah, pseudo transitive inference rule. One other rule that is called composition. What is the composition rule? Composition rule means x tends to y and z tends to w. Then we can combine those functional dependency into one, that is makes the x z tends to y w. This is called decomposition rule of inference. So these are the some rules that we can use in a normalization questions. First three are called Armstrong axioms. Second are normally called inference rule. So in some another books we can say that the primary rules and secondary inference rule. So this is called Armstrong's axioms. For the practice purpose, we have a relation R1, R2, R3, R4 and R5. We can find out the closure. How could I find the closure in particular relation? Suppose we can talk about the R1. R1 we have a three type of dependencies. A tends to B, BC tends to D, and AEG tends to G. And find out the AC plus, the closure of AC. How we can find out the closure of AC? And then the second, we can find out the closure of B plus. In third relation, we can find out the AB plus. And in the fourth relation, we can find out the BCD plus. In the last R5, we can find out the AG plus. So these are the solution. In the first solution, we can talk about the functional, closure of a AC plus. For the closure of AC plus, we can find out the ABCDE, that is the closure of R1. In the R2, we can find out the closure of B plus is BD. And the third, we can find out the closure of AB plus is ABCDE. And the find out the closure of valid BCD is H. In the last, we can find out the closure of AG plus is this one. So this is the question that is for the practice purpose only. We can find out the closure by using these functional dependencies, because we have used in the normalization question. Right. And another type of question we have faced in the normalization, that is the equivalency of the functional dependency. Suppose we have find out the two functional dependency and find whether these two functional dependencies are equal or not. So how we can find out the equivalency of the functional dependency? Suppose we have a functional dependency 1 and we have a functional dependency 2. These are the two set of functional dependency that we have given. So on the basis of functional dependency 2, we can find out the A plus AC plus and E plus. How we can find out these attributes? Because these are the left hand side of attributes that we can find the closure of the functional dependency. So find out the functional dependency of A plus, AC plus, E plus in the functional dependency 1 set. In the functional dependency 2, we can find out the closure of A plus and E plus. That is the left hand side of the attribute. If we have find out the functional dependency on the basis of, in the functional dependency 2 on the basis of functional dependency 1, in the set of functional dependency 1 on the basis of functional dependency 2, and functional dependency 2 is a subset of 1, then it is called equivalent of each other. If the FD1 is subset of FD2 and FD2 is a subset of FD1, then it is called FD1 equal to FD2. This is the equivalency of functional dependency that we have used in some questions that is comes under the normalization. Suppose these are the two functional dependency. This is another question that is given in X and Y. These are the two functional dependency. In X, we have a functional dependency P tends to Q and Q tends to R and R tends to S. In the Y, we can find out the two functional dependency P tends to QR and R tends to S. So we can find out the equivalency of functional dependency. On the basis of this is not equivalent to X and Y because X is a not subset of Y, but Y is a subset of X, but this one is not a subset of Y. So it is called not equivalent. So X is not equivalent to the Y. This is the functional dependency equivalency questions. So next topic is canonical cover. Canonical cover set of the functional dependency may have some redundant dependency that can be inferred from the others. Suppose we have a example of A tends to B, A tends to C, that is redundant in A tends to B and B tends to C. How we can find out the canonical cover? Basically, canonical cover is a minimal set of functional dependency equivalent to F having no redundant dependencies or redundant part of dependencies in a given dependency. Suppose example, we have a two type of functional dependency. One is A tends to B. Part of functional dependency can be redundant. That can be simplified by this. A tends to B and B tends to C, and A tends to C, D can be simplified into the A tends to B and B tends to C on A tends to C. If we can simplify this and simplify this is the C is the extraneous attribute. So we can reduce that particular set of functional dependency for the purpose of canonical cover. Suppose let's say example of this R is a relation and these are the functional dependency. We can expand all the functional dependency in this format by using these steps. We can expand these functional dependency and final functional dependencies are this. Again check the functional dependencies because it difference the WZ tends to Y is essential. So final dependencies are this one, X tends to W and WZ tends to Y and Y tends to XZ. That means this is the canonical cover of this particular question. Because we can use these steps, we can find out all the possibilities of the functional dependency, so we can minimize the functional dependency that are essential for the relation. That is called canonical cover of that particular relation. Basically, irreducible set of functional dependency. Now next is extraneous attribute. What is extraneous attribute? That is extra in a functional dependency. It is called extraneous attribute. Suppose we have an example of functional dependency A tends to C and AB tends to C. Then C is an extraneous attribute because logically it is implied that A tends to C. Suppose we have taken example of A tends to C and AB tends to C. Then if logically we can say the A tends to C directly. So B is a extraneous attribute in this type of functional dependency. In some question we have find out the extraneous attribute. So that's why we can discuss in there. Suppose we have taken another example of canonical cover. These are the functional dependencies and relation, and we can find out the final output of this much. A tends to B and B tends to C. That means this type of functional dependency we have given, and finally we can find the canonical cover of this one. How we can find? We can combine these functional dependencies. The set is A tends to B, C and B tends to C. So A is an extraneous attribute in this set and C is an extraneous attribute in this set. So by using these steps, we can combine these functional dependency into this, and this is the irreducible set of this type of functional dependency. So this is called canonical cover of this particular question. The canonical cover is a basically irreducible set of the functional dependency. If we can reduce that particular functional dependency, then relation can be break. So minimal cover or canonical cover is a minimal set of functional dependency that can preserve the functional dependency relation in a particular relation. Now the next topic is keys. In the key is a set of attribute which is uniquely identify a tuple, or key is a set of attribute that can you help identify the value of attributes. In a key, we can find out the closure and we can find out the super key and candidate key also. Suppose we have a relation in R and functional dependency is given, we can find out the closure. After find out the closure, we can define the super key and candidate key. In the first relation, we can find out the closure of this one, ABC plus. Find out left hand side of the attribute. We can find all the closure of left hand side attributes. And after the find out the closure, we can easily identify the super key and candidate key. In the first example, candidate key is A and super key is ABC, AB and A. These three are the super keys and one attribute A is a candidate key. In the second relation, we can find out the closure, and after the find out the closure, we can find out the super key and candidate key. In this also same way, we can find out the super key and candidate key. In the definition part, we can say that the super key is a set of attributes that can help you identify all the attributes. In a candidate key, a super key is a candidate key whose proper subset is not a super key. Either it is called candidate key. Primary key can be any one of candidate key that can be primary key, and the super key that all attribute that cover the identify the tuple of a relation, that is called super. In these examples, we can also find out the candidate key and super key concept. And in the concept of keys, basically these are the three examples for the practice purpose. How we can find out the key of how many number of candidate key and how many number of the candidate key. So we have these are the relations, and these are the functional dependency, find out the closure of that functional dependency, and after the functional dependency we can find out the number of candidate key and or candidate keys. So in these three type of example for the practice purpose, you can easily find out the same way that we can find out in this example. Suppose like example this. So these are the concept of keys: super key, candidate key and primary key. Primary key basically primary key is also a candidate key that can be suppose we have a take example of a record of employee. Suppose employee ID, employee name, and employee mobile number, and employee address. So in this particular table, we can easily find out the candidate key, and employee ID is the candidate key that can be also a primary key, because this is a unique attribute that can be used for the identify all the records of employee table. This is all about the concept of keys. Thank you so much. Thank you.